A research helmet cut engine noise by 40 decibels below 200 hertz. So why do voices survive? That is not silence everywhere. It is silence in one narrow part of sound. Consumer ANC usually breaks down above about 1 kilohertz. The question is, what invisible rule draws that boundary? Noise-canceling headphones promise a private bubble around your ears. A train rumble drops away. An air conditioner turns into a dull trace. Then a nearby sentence cuts straight through the bubble. An alarm chirp does the same. That mismatch is the whole mystery. The machine is not choosing sounds by meaning. It does not know engine, voice, or alarm. It only sees pressure changing at the microphone. So the real question is mechanical, not psychological. The obvious answer is simple destructive interference. A microphone hears the incoming wave. A chip flips that wave upside down. The headphone speaker plays the flipped wave into your ear. Peak meets trough. Pressure cancels pressure. Paul Lueg patented that anti-phase idea in 1936. Amar Bose began chasing it for headphones in 1978. Aviation headsets brought the idea into the field by 1986. That explanation is true, but it is not enough. If upside down sound were enough, every sound would vanish. Sound in air moves at about 343 meters per second. That speed turns frequency into physical length. A 1 kilohertz tone has a wavelength of about 34 centimeters. The average ear-to-ear distance across a head is about 21 centimeters. Those two lengths are uncomfortably close. Above about 1 kilohertz, the wave changes too much across your head. The headphone can cancel one spot and miss another spot. Low rumble has longer waves, so the ear region behaves more uniformly. That is why engines are easier than consonants. A specialized motor helmet proved the low frequency advantage below 200 hertz. It reported roughly 40 decibels of engine noise reduction. But a helmet is a controlled geometry, not a city sidewalk. Real life throws reflections, head movement, wind, and sudden attacks. The anti-wave must arrive before the unwanted wave becomes old news. That creates the second limit, the signal chain. A reference microphone samples the room. A converter turns air pressure into numbers. A filter predicts what will reach the eardrum. The speaker pushes back with the inverted pressure. Many systems use an adaptive approach called filtered X least mean squares. It keeps correcting the anti-wave as the ear seal changes. But correction is not magic. A sudden clap gives the system almost no future to predict. A steady engine gives it thousands of similar cycles. That is the hidden advantage of boring noise. Hardware decides how much prediction a headphone can buy. Sony describes 4 ANC microphones in the WH-1000 XM4. Apple lists 8 outward and inward microphones for AirPods Max noise control. More microphones give the chip more ears around the problem. They also consume space, power, and product budget. Apple advertised AirPods Pro ANC adapting 200 times per second. Sony claimed its WH-1000 XM4 adjusted over 700 times per second. Those numbers are not decorative. They are attempts to outrun changing noise before phase slips. Then the third limit appears, product reality. In aviation tests, one pilot headset delivered 19 to 32 decibels with ANC on. The same headset delivered 13 to 27 decibels with ANC off. That is a real active gain, sitting on top of passive isolation. Another tested headset managed only about 10 decibels of consistent protection. Same category, very different outcome. The label says ANC, but the system underneath is not standardized silence. Fit changes the acoustic path. Comfort limits how aggressively low frequencies get suppressed. Battery limits how much computation runs all day. A huge market pays for those trade-offs. Earphones and headphones were estimated at $45.5 billion in 2024. Wireless earphones alone were estimated at $30 billion that same year. That money turns cancellation into an arms race. So ANC is not one technology. It is a stack of constraints. Physics decides which waves can share a cancelable shape near your ear. Engineering decides whether the anti-wave arrives accurately and quickly. The market decides how many microphones and chips ship in the box. Low-frequency rumble sits where all three constraints are friendly. It is long, repetitive, and predictable. Speech sits where the constraints start fighting each other. It carries shorter waves, changing sources, and sharp timing edges. Your headphones are not failing when they leave voices behind. They are revealing the boundary of destructive interference. That makes ANC a perfect systems lesson. A product feature can sound like magic from the outside. Inside, it is physics negotiating with hardware. Hardware negotiates with batteries, comfort, and price. Marketing compresses that negotiation into a single toggle. That toggle erases rumble best because rumble is the solvable problem. The remaining voice is not a bug in the promise. It is the part of the world the system cannot cheaply control. Every clean interface hides a boundary like that. There's a hidden system behind almost everything. Subscribe and we'll find the next one.